Good afternoon, good evening, good morning from wherever you're joining us. And welcome to our webinar series called Experts Speak in association with IABAC, the International Association for Business Analytics Certification. And today we have with us the founder of IABAC, Mr. Hans Wolpers, joining us from the Netherlands. And he will introduce our guest speaker for today, Mr. Saikat Saha. Over to you, Hans.
Okay, thank you very much. I welcome everybody here to this webinar. And I'm very happy to introduce to you one of the authorities on the area of AI, Saikat Saha. He's working for Nescom AI. He is currently the technology director at Nescom AI, and in this role, he is supporting various AI-related initiatives of Nescom and driving the technology charter to promote innovation, trust, and AI adoption at scale. Saikat is an experienced AI leader and has been into data science and AI space for more than 20 years in various roles, including university faculty member, a corporate research scientist, and of late as AI ecosystem enabler. Prior to Nescom, Saikat has worked for Conduent Labs, GE Global Research, and Linköping University in Sweden. Saikat holds a PhD in applied statistics from the University of Twente, and so has even studied in my country. Master's and Bachelor in Engineering from IISc Bangalore and IIEST Shibpur in India. So Saikat has a very big background in all the educations and theories of artificial intelligence, but in Nescom and also prior to Nescom is more and more into making these theories work in the real projects. And specifically Nescom is running several very large projects to make AI happen in the real world. So I'm very happy to learn from his experience and hear what he has to tell to us. Saikat, the floor is yours. Thank you.
Thank you, Hans, for your introductions, and thanks, Ram, for providing me this platform. I appreciate it very much. Hello, everyone. I welcome you all. Good morning, good evening, or good afternoon, based on your current, where you are, current timing. So, yeah, I'm happy to be here, and I'm looking forward to the sessions on these large multimodal models, its current landscapes and future directions. So before starting, let me tell you that, okay, this is going to be a tech light sessions because I don't know the background of the participants. So that's why I have kept it on a very top view level. Okay, all right, so let me move to next slides. So before we delve into the subjects, let us first take a look at some of the major AI headlines from last year. 2023 was indeed a year for Gen AI, particularly so for LLM or the large language models. What we have seen is a Cambrian-like expressions in terms of availability of the different LLM models in that particular years. Whatnot from proprietary to open source models, from very vertical specialized LLM to multilingual LLM. So many models certainly popped up during that time, and this space is still continue to grow. And as we know, like these LLM models are compute hungry, they require a lot of computations, and that in terms has created a tailwind for the GPU makers. Naturally, we see that, okay, I mean, the GPU makers like NVIDIA's are doing a very big business nowadays. The board members for the corporates, they have certainly woke up, and they are saying that the Gen AI is real. It is going to stay, and now they are scrambling, a future-proof ready roadmap just to prepare for that Gen AI roadmap. And certainly what we have seen is that the responsible AI has become the talk of the town. So overall, 2023 marked the rise of that large language models. We understand that okay, LLM is hugely popular, but what are the factors that drives that LLM's superiority over, let's say, the traditional models? Let's take a quick look on that. So what I find here, mainly three factors. One thing is the change in the modeling paradigms. Earlier, traditionally, we used to do a very task-centric modeling, where we used to train the model on a small scale, well annotated data. And once this is ready, the model is trained, we used to deploy that. Now the modeling focus have shifted from a very task-centric modeling perspective to a very generalized model, which can achieve multiple tasks. So in this paradigm, I mean, what essentially people are doing, they are first, pre-train the model with a hyper large scale data. That data may be noisy, and then that model can be deployed, like with zero shots, or will in some cases, if zero shot doesn't work, like okay, a few shots prompt, and that is working quite well. So that's the fundamental shift since modeling paradigm. That's number one. So I mean, we have the models which can do more generalized and multitask model. The second point is that not only these models can, once they ingest the data, they can provide you with the analytic insights, but as well, they can provide you content like a human generally used to create. That's why the name generative AI has come, the generative part of the generative AI. And the third factor, to me, the most important factor is like that these models have given, simple human-like interface. I mean, like you can use chat to interact with those models, and that has created the, democratizations of those models. So using those AI model has never been so easy before. So just typing or chatting with the models, you can just work with the models to get your response. So this, in fact, has created what Netscape has done, for the internet in the mid-90s. So this is really a Netscape moment for the Gen AI. But yeah, we understand that, okay, LLMs are super and immensely powerful, but, their limitations become apparent when, let's say, we are dealing with, data modalities beyond the text modalities. So these LLMs are basically text in, text output systems, meaning like, okay, it can take text as an input and the outcomes are also text. Whenever they need to integrate, let's say beyond text modalities, it doesn't work well. So that is well known in LLMs. On the other hand, there are so many important applications, where you have to go beyond the text modalities. Text, for example, like that customer analytics, or let's say call center analytics. When a customer is making a call to a call center, the call is first being recorded and is transcribed, meaning like this note, that call is translated into text. And that transcript is being fed into LLM to do, among other things, let's say the customer sentiment analysis. So, but this is, okay, something you can get it, but do you think this is optimized? The reason is like, okay, I mean, when the customer is making a call, that call, the sound is also available. And that call contains, among other things, the pitch, the tonality, or, the loudness of the speaker, and which in a way directly related to the customer sentiments. So don't you think that including all those, I mean, like the voice or sound, along with the transcript makes sense? So this is just one example. So there are, I mean, tons of examples where we have to go, I mean, beyond the text modalities. Take for examples, I mean, I have included a couple of others here. One thing is like the video surveillance. So if you want to do a surveillance through a video, for example, you need to, interact with the video modulators, which is essentially some collections of images and the sound therein. Similarly, take the example. So let's say if you're curious enough, so if you want to do that, so you need to interact with the, these image modalities. So we see, there are a lot of important applications where we have to go beyond that text. And that set the stage for the multimodalities. But in fact, these multimodal AI models, it's nothing new. It's not anything like that we have started, we have woken up. I know there is a considerable research effort for the last 40 years, I would say, with the multimodal systems. But they are specific to, like a single task-centric, where the task is defined and the models, the model efforts are being defined to, make the end results. But as what we have done, let's say we have NLP models earlier. So from there, we have moved to more generalist LLMs. Similarly, we have the multimodal model that can cater to the multi-data sources. So how we can go to the from multimodal task-centric AI models to the next steps? That's the questions. And the answer is very obvious, is the large multimodal models. And that's the, the focus of our talk today. LLMs, or the large multimodal models, are basically, it consists of a language model component. This is the common space through which the information is shared. And along with that language model component, there are other data modalities that it can cater to. So please note that not all multimodal systems are LLMs. If within the multimodal systems there is not a language model, then it doesn't fit to be an LLM. That's the distinctions. So maybe moving to the next. So here, I'm not going into the technical details very much, but I would try to give you very high-level overview how multimodal models works. They are essentially, of course, if you can see in the literatures, there are many taxonomies. Different researchers and different practitioners use different taxonomies notations. But what I essentially have found out, basically two approaches to that large multimodal models. One is that so-called multimodal prompt. The other one is that multimodal agent. I'll come to that. So multimodal prompt is basically an end-to-end model which requires end-to-end training. And the very high-level architecture is like that. So let's say you have different modalities of data. So you require encoder for each data modality to create the embeddings. And once the embeddings for different modalities have been created, we need to align those embeddings of different modalities into a shared embedding space. And once this is done, you can use the language model to generate the next token, text tokens, not only conditions to the text input, but also conditions on the visual input as well. So it is that way it interacts with the visual component as well. And on the other hand, the multimodal agent is relatively simpler in concept, where when users invoke that, it is essentially an LLM, and which invokes first it plans what needs to be done, and then during the executions, invokes the tools. The tools can be open source models in the order of priority. Once the open source models are available, you first invoke and you try to execute them. If that is not available, you go to the next best, which is public or private APIs. And then even if that is not available, you try to generate code and the code interpreters to do the executions. This is in concept. And these tools can be, for example, the foundations models for visions or any other thing for speech or visions or anything. So yeah, I would focus a little on this multimodal prompt. The first and very successful multimodal model in these directions was Flamingo. Although this was not designed for that prompt, but more towards like task completions, not going into the details. But the Flamingo essentially, consists of a clip, very popular model, which is not the multimodal model, but which was created by OpenAI, to train the image and the captions in a joint space using contrastive loss. Not going into the details again, just to keep it simple. So Flamingo, we can loosely say like, okay, it's a collections of clip and a language models, and it generates the next tokens, conditions, and not only on the text, but also on the visual input. So based on the Flamingos, over the times, there are different sophisticated models that had appeared in this space. So, I have given here the reference, like for important details, one can look at the different models and their evaluations. So I am skipping that part in the interest of time. Similarly, there are different multimodal models that have that agent models that has appeared over the times. Here I have listed only a few, like this MMReact, Viper GPTs, leading up to Gorilla and Assist GPT. How we can compare those two models? One hand, we have this multimodal prompt. This is like requires, as I said, end-to-end with training. So for that we required curated data, and creating that curated data is not that non-obvious. It requires a lot of efforts, and that's why the results also depend on the type of data you have. On the other hand, this multimodal agent, this agent-based approach doesn't require any training, which is very good. And they can leverage, what is available off the shelf. So, be it the models or the APIs, or if both of them are not available, as I said, we can go for a code interpreters as tools. But the problem here is that, how to select those tools? So if the tools that is selected is weak, then the performance is also weak. So that's one problem. So there are pros and cons to both the approaches, and currently, both are subjected to heavy, research efforts. So hopefully, we will see lot of research in those two directions broadly. So now moving on to the next phase, what are the emerging capabilities of those large multimodal models? So interestingly, the LLM have shown to perform many things which have we couldn't have imagined even before. Take, for example, the latest examples, like let's say you have 3 bills and you are asking your these models, let's say, what is the total amount of tax and how they are arriving at it. And surprisingly, they are doing multi-images understandings. This model can tackle that and give you the correct answers in majority of the time. This is amazing. One example. The second one, for example, you take like there is a input pictures provided by, let's say, the users, and we can put any pointed region. It is by us. We are making a pointed region, and we are asking the model to describe it, or do whatsoever, or even sometimes manipulations of that. And the model can do that, and see how the flexibility has been provided over the time. These examples is also a very interesting example. So you see the cluttered background. Also in the font, there are images describing the parking rules. It's a hugely complex, so many rules, and that too, over different image, different paths. And the model can read them and also, answers to your query. This is surprising. This is really a very good example that the LLM can do. Apart from that, of course, this space is growing, and lot of examples are there. Just I would like to mention the other two here, briefly touch upon that. One thing is that the video summarization. So here we are asking the model to summarize the video step by step with the instructions things. So, and they are providing, for examples, how to create that footage. This is, like the food blog video examples. So how to, add different components, and that summarization is there. Finally, this is from the image point. So let's say you have an image with the birds crane here. And also you have the sounds of waves, sea waves, and together can you create a new image where the birds can be seen in the near to the sea waves. So even that is what possible right now with the multimodalities. So there are a lot of interesting applications, and these imaging capabilities are coming out for the large multimodal models. I would briefly touch upon the use cases here. I have taken only a couple of them, but this space is also growing. There are lots of interest from industries on these use cases of multimodalities. Let's look at that industrial safety inspections here. What we can see in the image, there are multiple people who are going to the industries or factory. Some of them are wearing helmets and some of them are not wearing helmets. And the mandate is to check, first of all, how many of them are wearing helmets, then identify who is not wearing helmets and to make a report generations, let's say. So to do that, if you use that, amazingly, these LLM models, here it is the GPT-4, the visual versions. This is doing excellent jobs. But if you ask how many persons, we have seen, like how many persons are wearing helmet, sometimes it doesn't give the good results. Not the exact results, but if you ask, whether each person is wearing helmet, then count the total number of persons wearing helmet. It is actually, first composing and breaking down the tasks. So they are just grounding that. First, object detections, then the object localizations. Once the objects here, the persons are localized, then there is a classifications technique, like, okay, whether wearing helmet or not. And finally, the total number of counts of the helmets. That's there they win. It's amazing, the way they are doing. And this is a very good use cases, and I see a lot of potentials to win. The other use cases is like, the defect detections. Here, the defect detections is being done using the popular approach as so-called spot the difference, in which, you are giving a reference image, which is not, which is undamaged, or let's say there is no defect with, and you are providing the other image, and the model is comparing the other image to the original, or let's say image with the no defects. And actually it is, in majority of the time, it's very successful in giving that. We see, there are still a way to go. For example, the right-hand side, there are outcome which is not true, which is marked in red. It is saying like the center cap is missing, which is not the case for this in examples. There are, still some, rough creases. Over the times, the model developers need to address them. But overall, there is a lot of potentials, I would say, with the defect detections in the coming days. Of course, the other important applications would be like radiology report. First thing is like, getting a report, and also, expert, as if like the radiology experts. So can you do it? And if you can do it, as the number of radiologists available is currently short, so if we can automate some part of that, we can reduce the burden of the radiologists. That's the approach. And also, in a way, if it can be done in a proper way, in compliance with the existing regulations, then it can also reduce the cost and also the execution times. So there are a lot of potential impacts to each of those use cases. What we have seen here is that in the case of medical radiology report, it is doing kind of okay jobs, but sometimes there are, problems. So like here we can see like, okay, there is a hallucinations in it. It is giving the dimensions of, it is measuring some things which is not correct. And also it is saying something in the left, but in original, although it has detected the correct things, but it is saying the detections region is in the opposite side. So, but in medical, we cannot go with that. There are a lot of regulations, and that's why we did more experimentations, and over the time enrich the models before we can get a very good model to go with that. So uh, still, where to go at least in the medical domain, but in other domains where it is not so scrutinized, there are immediate potentials to use those multimodal use cases. Finally, the last use case, what I have included here is the auto insurance. One part is like, describing the damage, and second part is like, generate the damage report. Once it is asked to the model is actually doing a very reasonable job. So, for example, see, this is, what we have given the prompt. As an expert, the model is evaluating the car damage. And also, not only that, they are reporting in a certain format, like in JSON's format with, the placeholder XXX. So when there is nothing, it should be reporting as like a not applicable. And it is reporting the make, model, license plate, damage descriptions, and also estimated cost of repair. So, see where it has gone. These models is generating those reports, even if they are just, generating those sort of reports, and the turnaround time is very quick, So that can reduce a lot of screenings for the physical examiners. So huge potentials even in the auto insurance sectors. So finally, I think, yeah, I am within the time. So I have also listed some of the challenges and also the emerging directions for that. As we know, even there is a compute challenge even with the large language models. It requires lots of compute. So just think about, when you are going modalities beyond the text. So this is definitely a challenge that requires attentions. Not only that, there is also a challenge with the data management. So like the data is huge, large, and also like the heterogeneous, consisting of different modalities. There are also challenges with the how to evaluate. What are the matrices and the benchmark? Given that it is a loosely open-ended, there can be different modalities. Although now majority focus is text with images or text with video. Video means only the without the sounds. But there are other modalities that needs to be incorporated and expanded. So given that the other modalities may sit there, so what would be the common matrices and the benchmark against which we can, measure the different models' performance? That would be an interesting area itself. And as I said, like some of the models requires, learning, and for that purpose, we need to organize the data well. Which is a tedious and expensive job. So can we do it in a better way or in an automated way or something? So we need to think about that. Also, training is a huge, like the obstacles here right now. It's a compute intensive. So can we do better training? So there are way, in terms of, quantizations and some other methods that have been proposed for the large language models. Okay. Similarly, can we borrow or borrow the strength of those efficiency training to that LMM domain? And there are others like continual learning. One thing is that, okay, whatever data we are training that models, that foundations models, but beyond that, they cannot answers to that. The data become dated with the limitations. How we can learn continuously? Like as the data are arriving, can we learn from the data continuously in this domain? And like the LLM, there is of course associated challenges like the hallucinations, corrections, and other things. So there are, I mean, couple of challenges we need to, carefully look through while dealing with these large multimodal models. On the other hand, there are like different emerging directions. What we have seen, like for example, can we generate interleaved image text content? Right now, the generation is mostly, let's say, either text or like the images, but can we do something, let's say, image, but text within that? For example, I mean, if we are just creating video tutorials, classroom tutorials, can we do that? I mean, it should be a video, but also instructions embedded in the form of text. The second point is the modality expansions. I have touched upon, like, okay, currently the major modalities are only text and image. So going beyond that, for example, so it can be like speech, I mean, the voice. It can be other things, the depth sensors, radar, LiDAR data, or for that matter, it can be, like the real physical world sensors, sensory, like touch and smell. So these are all in future possibilities, but of course, I mean, the way it is progressing, I don't see it would take that long. I mean, all sort of modalities, I mean, different modalities would come into play. The other interesting development could be, I mean, we have seen, okay, text-based search, and from there to like image-based search, that is already there. So we are seeing some emergence of audio-based search. So just given an audio, can we search the content? Or create, let's say, an image based on that input audio. So these are very emerging topics. Something like also like automatic tool creations. I mean, like if the for that multimodal agents, the tool we are invoking, how we can create those tools. So that's one part. There is already some effort towards that. Similarly, like this racked multimodal agents, this is a big topic even in LLM. So similarly, in the context of multimodal, it is also getting a lot of prominence and also attentions. And along with that, I mean, how we can benchmark those tools. These are some practical things that we need to, take care and look forward. And there is already some sort of movements towards that sort of things. With that, I would like to conclude and I hope that it is somewhat useful to have a very top overview with that. And hopefully I have completed on time. Yeah, I would look forward to questions. If you have any.
Yes, I could. Like, so we have a few questions coming up in the Q&A. So one of them is asking, how do large multimodal models handle different types of data inputs? Like, I think you were making some mention of it in the last slide. They're asking, how do large multimodal models handle different types of data inputs like text, images, and audio? I would like to add one more thing there. Like, have you heard of the new initiative from India called Bharat GPT?
So yes. I mean, NASCOM is also a bit partly involved in that.
Yeah, that's a voice-based data input, right? Audio-based.
Yeah, it can be voice-based. It can be also text. I don't know the nitty-gritty, but yeah, I mean, it can be also. I mean, both. Voice is also one option, definitely.
So how do these models handle different types of data is what they're asking, like, text and voice and images and all. So can you tell us more light on that?
Yeah, sure. As I have covered from a very broad overview, like one of the approach, like, okay, you have different modalities, voice, text, and others. So what you are doing, you are passing through, for each modality, you have an encoder, which essentially what it is doing, it is generating the embeddings for that modality first. First, modality specific embeddings we are getting. And then what we are trying to do, align those embeddings into a common embedding space. And that's the technical things. But yeah, I mean, let's say if we can associate, let's say the correct pairing, no, let's say the correct boys or let's say correct text with the correct image. If the embeddings are, I mean, nearer, I mean, the for similar, I mean, like the pair. If the pairing is right, the embedding should be aligned. I mean, meaning like that image and text embedding would be closer as opposed to if they are not the correct pairing. So we are making sure in some way that the in common shared embedding space, they are closest, I mean, the correct pairing. So just to give you the ideas, I mean, how it is been done. So that's one thing. And those that multimodal, not the agent based, the other one, prompt based things is actually this is the approach. Does that clear or answer your questions, Ram?
Yeah, yeah. And we have another attendee asking,
Sure.
are there any ethical considerations like, for buyers when we use large multimodal models?
Yeah, that's a genuine. I mean, this is interesting questions, and not only it involves the technicalities, but as you know, like the policy
Yeah, we
space.
know what happened to Gemini AI, right? I mean,
Yeah.
yesterday.
So of course it is there, but it is there not only for LMM but also for other foundations models like large language models itself. But I understand, and also since the I mean even with handling one modality is so complicated, so how it can be? I mean, I can imagine like handling multimodalities would be very difficult. For example, I mean, if you are just searching for, I mean, some days ago it happened, no. So when people experimented trying to search for like the I mean poor the I mean images of black people came out, I mean which is not desired, I mean so that the bias these things are there, but the researchers are active and they are just trying to mitigate, if not eliminate, but at least mitigate to an extent which is, I mean, possibly acceptable. So this is a research topic, and also not only research topic, it's also an policy planning topic. I mean, what is your tolerance and what is your guidelines? So in both ways, there are considerable work happening, and I'm sure there will be more light to it. Anything specific here? I mean, if I have missed, please.
No. I think you covered most of it, man. So one of our attendees is asking, like, what kind of computational resources, right? Like, is it any different than what the LLM models, need, like, in terms of resource heavy, hardware resource heavy kind of, needs for large multimodal models?
It would be because I mean, if you see the models, the training, that I mean, in large language models, you are training only single mode, and you are just I mean, just imagine, I mean, you are getting the embeddings or whatsoever for a single mode. Yeah, I mean, like you are expanding that to a multimodal space. Obviously, the computation is higher, so the compute requirement would be higher. And not only that, I mean, you are dealing with large data as well. So earlier, it is only the text data, but here you are just pairing text data with, let's say, image data. So in terms of data is also huge, so managing that data is also a challenge, like heterogeneous data, different sorts of things. Storing and managing them is also, it required careful considerations, definitely.
We have Razimore asking, is there any live prompt for testing LMM?
What is the platform?
For the, like a URL, to test for any kind of models, like, I don't know
Yeah,
what.
I mean, like the BART is giving and GPT-4B. I mean, some of them are not open. That's the problem. But there is. And like I mean, there are different models that is available. You can, I mean, they are open source. I mean, like one can experiment with.
Yeah, and we have another attendee asking, yeah, maybe the use cases is what they're referring to. They're asking, can you give me some more common applications of LMM across different industries?
I have included some of them, but I admit, I mean, there are lots, and people are very imaginative. No, they are coming out with lots of use cases. Like for example, so I have an included here. So people are finding it easy to, create a code for that. I mean, you write in a paper whatever you require, and you give it as an input to some of those large multimodal models, and it actually is creating the web page for it, and which is working, I mean, quite good. It can create HTML, for example. So even like, it can read a table. I have seen those, and it can generate, the latex like table and create it. So in terms of that, I mean, this is a very creative elements, and imagine in terms of productivity. So like we used to take lots of effort to code those things, code testings and others. Right now, that GenAI or this, in this case, large multimodal model, they can, if they can to some extent, I mean, forget about the perfections right now. If they can, leave that heavy lifting up about, let's say, I mean, major questions of the code writing, then you think about the productivity. There are a lot of use cases. There are a lot of use cases which are emerging and very interesting, I would say. So I tried to include some of the industrial applications, a little, I mean, broader perspective from medical to, that insurance. But of course, there are plenty. And if you see, I mean, in the literature, including some of the references I have included here, you see lot of use cases people are referring to, and they are quite imaginative and creative.
Yeah, we have a last question we can take.
Sure.
They're asking, can LMMs be used in predicting or in identifying species using training data sets? Or is it considered an application of, I think...
Species mean like the different animals and those things, or the...
Yeah.
Definitely. That's one of the applications, no? See, the way, I mean, like, be it a large language model or the extensions to large multimodal models, it is trained on a humongous amount of data. It's like a, extra large hyperscale data set. And it is trained, and then the thing is that it's like I mean, the way we have shifted our focus or the modeling attentions. Earlier it used to be close set classifications. I mean, whether this image contain a bird, or let's say, or an animal or something. But right now you can just put anything and you can ask like, okay, what is this? I mean, and they, I mean, like some sort of, we have moved from close set to an open-ended space. So given your input, what is the the nearness of that, whatever is available in that model. The model has captured a lot of info while the training is given from the data. So we try to answer based on that these open-ended classifications. So yes, I mean to that extent, whether I don't know whether I was able to explain to you, but definitely the answer is definitely it can identify in majority of the cases about the species and also new plant species or let's say animal species. Definitely, it is an application there.
Yeah, thank you so much, Saket. And I
Thanks,
think that
thanks,
is what we'll take. And to all the participants, like, please visit iabsc.org to join and become an authorized training partner with IABSC. And we will keep you all posted on all our upcoming events by email and across all our social media channels. And looking forward to connecting with you guys all soon. And thank you so much, Hans, for joining in. And thank you again, Saket, for joining in. And thank you all for attending today's session. And have a nice day, everyone.
My pleasure. Thanks, Ram, and thanks, Hans. It was really nice interacting with all of you, all the participants here. Thank you.
Brilliant.
Thank you as well for your input, and thanks for this wonderful seminar. Thanks. Bye-bye.
Bye.
Bye.
Have a nice day.